Very good morning to all, and some of you is a good afternoon and good evening. Welcome to another Health AI virtual discussion with Sriram from NIST and Gopal Khanna from Health AI Institute.
Thank you, Ikram, and welcome to all of you who've been able to join us within the United States and overseas. We appreciate your being here today. It's a very important discussion. Just to set you the framework, in 1901, an organization was established called NIST, National National Institute of Science and Technology, Standards and Technology. Ram, please forgive me. I'm sort of mixing up the acronym.
No, that's
over
okay.
here.
A lot of people make that mistake about science and standards.
Yeah. But NIST is part of Department of Commerce. It's an extremely important entity that was created literally over 100 years ago to make sure that we have developed measures so that our products could compete with, at that time, England and Germany. And over the years, over the last 100 years, NIST has done a remarkable job in making sure that measures are created and they are embedded, technology is embedded into everything. And that's where NIST's work comes into play in making sure that standards are developed that can be effective and efficient use of the technology. NIST's work is particularly important at this point in our nation's history when we are getting into the age of AI. And today we are really pleased and honored to have with us Dr. Sriram from NIST. He's based in Washington, D.C. He's currently the chief of software technology and is focusing his work hugely, not just in AI, but in the healthcare and life sciences space as well. Dr. Sriram is recognized in the industry. He has either authored or co-authored over 300 papers. He earned his undergraduate at IIT Madras, a very leading institution in the world. A lot of people know about IITs of India. He then came to the United States, earned his MS and PhD at Carnegie Mellon, went on to teach at MIT, and now we are really happy that he's at NIST because we need someone like Sriram to usher in the right kind of standards and lead us all, the industry, to really prepare for this explosive growth and innovation opportunities that we have before us as a nation. So with that, Ram, the virtual floor is all yours. Please take it from here. Once you're done with your presentation, we will have a Q&A session, as Ikram pointed out. I would urge the audience to please submit your questions, and Ikram, at the end of the discussion, will put them all together and make sure that Ram is able to address at least some of them. With that, Dr. Sriram, the floor is all yours. Thank you.
Thank you very much, Gopal, for that very kind introduction. I will share my presentation. I have a lot of slides. I won't be going through everything in detail, but I will make the presentation available to Ikram and Gopal, and you can get it from them if you want.
Thank you.
I'm going into the share mode now. I'm just trying to figure out which is right. Yeah, but I won't be able to see any chat or any such notes. So if there is an issue with my presentation, if you cannot see something, please let me know. Can you see my presentation, Gopal?
Yes, I can.
Okay, let me go to the presentation mode then. And right now it's not in a presentation mode. Okay, now can you see the presentation mode?
Yeah, it's good.
Yes, right.
Yeah, good. Because last time when I gave it, people are only seeing the other half of this thing and they didn't tell anything. And I went through the whole talk and at the end found out that they were not seeing this full talk. Anyway, I'm going to talk about something called AI metrology, which is ensuring the reliability of artificial intelligence. So as Gopal mentioned, we are a measurements and standards organization. And we have several Nobel Prizes, almost 6 Nobel Prizes or so, which is based on for measurements. But that's more at the atomic level measurements for making clocks more accurate. And NIST is kind of a leading organization in these areas. So what I'm going to do is to first give a brief review to everyone, to bring everyone to equal level in a sense, I'm going to give you my brief review of what I think about AI and what has happened in the last 40 years of my life. I started working in AI in 1980, so it's been almost 4.5 decades or so. So I'll just go through a short description of evolution of these things. Then I'll talk about AI at NIST, and I'll talk about metrology, basically measurements for AI and AI for metrology. What do I mean by that? So metrology is the science of measurement. So we have to measure AI. I mean, people are talking about all these AI systems. Just like when you go to the pump and you put your gas in there, it says 1 liter. How do you know that it's liter what you're getting? And that's traceable to NIST. So these are physical units. And then similarly, time, a second, a kilogram, all of them are traceable to NIST from a physical sense. Now we are in an era of information age. So which means that we need to have measurements for this information technology too. And information technology, AI is a kind of information technology. So we are talking about how do you measure AI? Then AI can also be used for helping in measurements. As he said, as Gopal said, NIST is a measurement lab. So we actually use artificial intelligence techniques for actually doing better measurements. And I'll briefly, depending on the time, I'll talk about that. So in terms of artificial intelligence, here is a simple view of AI, which is concerned with the development of computer programs that emulate the intelligence of humans. Now, what's important here is that you have the environment, then you have the perceptions, like you're seeing things, and not only you're seeing things, you're hearing things, you're tasting things, and all kinds of things. So that there's a perception, and the sensors kind of get these signals into your brain, and your brain is the one who's the intelligent who is going to do something based on whatever you're receiving from the outside world, and it's going to take some actions, either like now I'm talking, or a natural language, or by manipulators when you're talking about robotics into the environment. Now, this is the view of AI, but then people talk about what is intelligence and things like that. But I don't want to go into details about intelligence, but intelligence is several dimensions. Like, for example, Gopal mentioned about IITs. To get into IIT, you write an entrance examination, and basically they test you on only one level of intelligence. That is, how can you solve problems? There are other places of intelligence, like there is aesthetic intelligence, there's appreciation of music intelligence, there's muscular intelligence, there's lots and lots of intelligences. And Howard Gardner in Frames of Mind talks about this multiple intelligences. So anyway, that's a different story in terms of intelligence as such. But most of the time we talk about artificial intelligence, and some people talk about augmented intelligence. How do you improve the intelligence of human being rather than replacing the human being? And that's what is going in healthcare. It's going to happen in healthcare. In healthcare, I believe, rather than replace the doctors, if you can augment the intelligence of doctors, that will be very useful as such. So we'll come to that later on. So in terms of the evolution, there's a lot of things happening around here. It started around the Paleolithic, I call it the Paleolithic time, when the Indians and the Greek philosophers actually talked about this almost 3,000 to 4,000 years ago. And in India, we have something called the Vedas and the Upanishads, and they talk a lot about the knowledge representation. They talk about the inference strategies. They talk about a lot of these things. I don't know, these guys did this about 4,000 years ago. So anyway, but the key things that have happened is that there are 3 or 4 revolutions that we should be concerned about. The first one is the knowledge is power, which happened in 1980s to 1990s, when I will say briefly explain what that is. Then we have the neural networks, which came to the fore in 2000 and 2015. Then we have a symbiosis of neural networks and knowledge networks. Again, I'll come to that, what it is. And then finally, we have what is known as the conscious machine, which is going to be extremely difficult because we don't know what consciousness is all about. But people are claiming that the machines are going to become sentient, machines are going to be conscious. And that will be a very interesting thing in the AI and what will happen to the doctors of the future. And they call it as the tsunami, if that happens, if ever that happens, okay? There is a nice talk by Henry Kotz who actually goes through this evolution of AI, and there's a link there. So the knowledge-based systems, actually, the reason why I am talking about this is people nowadays, when they talk about AI, they're a little bit confused because they think AI is neural networks. That's not true, because AI started with this whole notion of trying to represent the human knowledge in terms of rules, ontologies, logic. Again, I can talk about hours and hours on these things, on how to kind of represent this. And then it's just like these ontologies are the rules that you represent. Then you have inference strategies like backward chaining, forward chaining, and so on. You act on these rules. That's how the original AI was all about in the 1980s. And there was a famous system called Mycin, which was developed for that. Then there's a second way, which is the neural networks, where people thought then, well, let's try to kind of emulate the human brain itself, because the brain consists of a lot of neurons interacting with one another, and neural networks kind of evolved from there. And while I was at CMU, there was a person called Jeffrey Hinton, and he used to work on neural networks. But interestingly, though, that at Carnegie Mellon University at the time, the more emphasis was on symbolic networks, as I talked before, not so much on the neural networks because of the computational problems associated with it. Now, if you look at neural networks, there are millions and millions of neurons, and there are billions of parameters of these weights of, if you look at the next slide, the multi-perceptron thing, you have these neurons connected to each other, and you have these things called weights are the parameters in there. So these are the weights which every neuron is connected to every other neuron, and there are some weights associated with it. And then the way this kind of thing works is that you teach the system, like for example, in this diabetic retinopathy case, you kind of tell the system that this particular person has got mild, moderate, severe thing, and the system will kind of learn this a function. And so in the next level, when you show a different eye image to the person, although this image was not taught before, it will kind of reason and say whether the person has diabetic retinopathy or not. And this is very good. It is very good at doing things. And the reason why these neural networks became doable is around 2020, in about after 2010, 2015 or so, NVIDIA was working on this graphic processors for video games and associated activities. So the chips kind of did what matrix multiplications very, very fast. So it so happens that if you look at these neural networks here, these are all matrix multiplications around here. You multiply this particular vector with some other vector and so on. So two things. So as luck would have it, these people are developing things for hardware for video games which required matrix multiplication. Neural networks also were doing matrix multiplication. And so both these technologies kind of converged, and it was a mutually beneficial proposition. I'm just going to stop it 1 second here and say, Gopal or Ikram, is the pace okay?
Perfect.
Okay. Yeah, good. Because if I say too many elementary things, let me know. I can just skip a lot of things. Okay?
No, this is very good.
Yeah.
We all need to understand the basics first.
Yeah. So then what's happening is that in terms of the neural networks, what they like here, there are lots and lots of images are shown to the neural network. And then that said that, well, this particular image is a cat, this particular image is a dog, and so on. And then the system kind of learns a function. Essentially, the network is learning a function. That's called the learned function. But what it cannot do is that it cannot kind of tell you why it did certain things. Can you trust it? Can you correct an error, and so on and so forth? It's not doing it. So around 10 years ago, DARPA started this project where they wanted to do called explainable AI, XAI, where now they want to say that, well, now we want to probe this thing a little more. We just don't want just some weights and things like that. Doesn't make any sense to us. Can you develop an explanation? Because, well, it's a cat because cat has whiskers, cat has furs, and it has these features and so on. Can you identify that? So that's the stuff that they've done called explainable AI. And neural net, and they did some research on that. But then the problem is that with the neural networks is a fundamental problem is here is a neural network which has been trained for identifying guitars and penguins. And the unfortunate thing is that if someone kind of identifies, let me see what happened here. Oh, if someone if you have this particular thing, some noisy image, it thinks it's a guitar, and this noisy image is a penguin. The system has learned a function, but people can fool it. Similarly, if you teach it for panda, if you what is that? Show lots and lots of panda pictures, and the system learned a function to recognize pandas, but someone introduces some kind of a small noise in here, it thinks it's a gibbon. And things can be more dangerous actually than that, than this particular thing. Like for example, Tesla has been, its neural network based systems learned how to recognize stop signs, but some guy put a post-it sign there, and he thought it was a 35 miles per hour. So you can fool the systems. These are called Trojans into the system. Okay, and it's very dangerous in in medical field, when you actually have medical images and someone can twist it so that even if you don't have breast cancer, it says you have breast cancer. So you have to be very careful on that. So there's this nice book by Arvind Narayan and Shayesh Kapoor, which came in called AI Snake Oil, which if anyone is working in AI right now should read this thing. But there are other books also. Daniel Kahneman, who was a Nobel Prize winner, actually first came up with this idea of thinking fast and thinking slow. He said, really, the human brain has two systems, system one and system two, whereas the first system is like the neural networks. It thinks very fast with it does pattern recognition very fast. For example, if you go, let's say, if I go to an auditorium in Hyderabad, where I was last 3 weeks ago, and there is a coiled rope, and suddenly when I see it, I think it's a snake because there are lots of snakes floating around there. But then my second thing, which is system two, I look back and see what would a snake doing in this auditorium? Because snakes generally don't get into auditorium. They make sure they get rid of them before that. So that is a second system. So the first system, the neural network system, is system one, and the knowledge-based system thing I talked about is called system two. And there are Gary Marcus and Ernie Davis wrote a book called Rebooting AI. Again, a very good book to read on if in the current things. I wrote a book called Intelligent Systems for Engineering in 1997. Actually, the book was written 10 years earlier, where in one of the chapters I talk about how neural networks, I talk about knowledge-based systems, and I talk about how these things should be combined together. And that is what the third wave is going to be, which is called the neuro-symbolic computing. So the thing with these neural networks is they're good at this pattern recognition thing I talked about, but they're not good at common sense reasoning. So we need to combine both these things. So there is, Amit Seth at UOSC, University of South Carolina, has been, I got a few slides for him. The idea is that now you need to combine both this perception, which is the one that we talked about, neural networks, and cognition, which is actually reasoning, into one framework. So you have system one, which is the perception, and system two, which is the symbolic AI, and you kind of combine together, and then you have this neuro-symbolic AI as such. So this is the future, I believe, in terms of the next stage of AI. Just sticking with all these neural network things and things like that, because it fails, as you can see. It thought that it's a 35 mile per hour zone. But if you understand the context, the knowledge-based system could have said, okay, it can be a 35 miles per hour thing because this looks more like a stop sign on the context. Similarly, in the medical diagnosis, it may diagnose it as a breast cancer, but you can say, well, this person is so healthy and so on, it cannot really be breast cancer. So you get knowledge into action. So here is how this whole thing works. Again, the details are not important here, except that you have the neural networks, which is statistical in nature, and then you have the knowledge networks, which are more symbolic in nature. So you need to combine both these things together. Okay. So anyway, there's something called predictive coding, which I'm not going to go into details, but if anyone's interested, this is developed in psychology, and it can be applied in computer science area, where you have knowledge networks and neural networks and data, and you can combine together. And this is something that we are looking at too at NIST. Okay, now that's so much a very brief background about what's happening in AI. So I talked about three revolutions or the three waves: the neural, the knowledge-based, and the neurosymbolic kind of waves. So then a little bit, I'll talk about NIST and what we are doing in these things. Now, as Gopal mentioned, NIST is more than 100 years old. We are part of the Constitution. Article 1, Section 8 talks about weights and measures, but then it all started with the physical weights. Now we are all in the informational things. So we look at standards, and so the key thing we have is measurement science, standards, and technology. So in terms of the NIST AI program was created almost a decade ago. So there are several kind of focus areas on these things. The idea is to conduct foundational research to advance trustworthy AI technologies. Now, one of the important thing with this AI is that if that particular system says you have lung cancer, or you have carcinoma of something, or you have colon cancer, or IBD or IBS, whatever it is, you have those things. How do you trust this AI system? I mean, do you trust your doctor? So how do you trust the AI system? What are the mechanisms for trusting? That's very important. So we do a lot of work in the lab, so advancing AI research and innovation across NIST laboratory programs. Then other things is establishing benchmark and developing metrics for evaluating AI things. So these AI technologies are coming. So how do you measure these things? What are the metrics associated with it? So that's one of the things that we do. The fourth thing is participate and lead in the development of standards to advanced AI innovation. Now, a lot of people think standards hamper innovation. About 25 years ago or so, I wrote a paper on how actually standards will improve your innovation. A simple example is the musical notation. Musical notation spurred hundreds and hundreds of years of creativity in music. Okay, it's a standard notation, but it created that. So standards put it in the right place actually will lead to innovative technologies rather than hampering them. You got to be is what it is. Then the fifth one is about the policies, and we do work with various government agencies on these issues. So because we have technical expertise and we provide this technical expertise to the development of policies. And finally, which is a little bit tricky here, is ensuring that we have the resources. It all depends on appropriations and so on. So then what are the products that we have come up with? There is something called the NIST AI NIST Risk Management Framework. And I'll talk about this briefly. We're also part of the NIST AI Advisory Committee, the Resource Task Force. We are the Federal AI Standards Coordinator, and so on. So as an example, here are some of the investments that we have made. The risk management framework, AI evaluation, and AI standard development are probably very important for you. So I'll go talk about briefly in each one of them. Like this AI risk management framework, okay? Every organization who's working in AI should go through this particular framework. Like, for example, this framework has about 4 categories like governing. In the governing part of it, you actually set up from your institution, your organization. You have to kind of develop this culture of risk management. How are you going to do it? It's more of policy kind of things in there. And then what you do there, you map it into a particular context, because you might have the generic notions of policies put in place, but you might have a particular context. Like, for example, you are doing about digital pathology or something like that. That's your context in there that you are working in. Then you have to develop the metrics. That's the measuring part of it. What are the metrics to measure these things, and how do you manage this? And in the NIST management framework, we do have each one of them have subcategories, and it will tell you how to actually achieve this thing. So if you are implementing AI in your organization, it's very important to read this particular document. And in terms of the standards activities, there is this ISO, IEC, JTC, SC2, and we participate in this particular standards organization. Okay, so then we also do international engagements with OECD. Then we look at, and again, through standards, we work with several international organizations, and we also look at working with different countries out there. Okay, like you can see Britain, India, and other places in there. So that's part of the NIST work. So in summary, from a NIST perspective, we do fundamental research in AI, and not only actually NIST is in the middle, but fundamental research is done in, we do some, but a whole lot of this fundamental research is done in the academia. We actually do the applied research. We do the standards and best practice guidelines, and this could be adopted. We help in the adoption process. So at these two ends of the spectrum, we are kind of involved, but most of our activities are in the middle, where you do applied research, and then we look at standards and best practice guidelines. And that's what NIST is about. Okay, then there's a lot of ways of interacting with NIST, and this is for the academic collaborators. So now I'm going to talk about metrology for AI. And before I go into metrology for AI, what I'm going to talk about, where can AI be used in the healthcare world? So this one kind of, Eric Topol wrote this very nice article a long time ago, but where he showed this AI can be used across the spectrum. In the spectrum, I call the spectrum as womb to tomb, like from the embryo selection at the womb level to the tomb level. Even actually, in fact, it's an interesting thing. Death requires AI too. Okay, it's not life. Like when someone dies, there's a lot of very interesting things that can happen which require the AI techniques to optimize the resources. And let's say someone dies in India, go to India to visit recently someone I knew went to India and the person died there. So the question is, how do you bring the guy back here to United States in an optimal manner so you can have the appropriate chat services in United States? So those are interesting things. And then you have, so there is something like, for example, patient safety. And there's another thing called value-based healthcare, which is very important. So in terms of the value-based healthcare, can actually benefit a lot from AI techniques. So you can give the best healthcare at the lowest cost. So then there are things like classification. I'm sorry, classifying. This is the one which is mostly people talk about AI is, but then there is a whole lot of other things in there. So, but then there is also a set of problems in there in terms of diagnosis, interpretation, monitoring, controlling, treatment planning, and you can take this spectrum to a little bit in three-dimensional way, where you can also look at the organ types like ocular, thoracic, breast, gastrointestinal, and so on. And then depending on where you are, use an appropriate AI strategy. Like for example, if I'm doing diagnosis, I can use I can use rule-based systems to do some initial diagnosis. I can do interpretation by image interpretation using neural networks. I can do monitoring, which may require both a combination of knowledge-based networks and neural networks and so on and so forth. And design is a very interesting problem, which requires all kinds of strategies. So depending on where you are and what you're doing, you use the appropriate strategy. Okay, so in terms of the metrology, just a brief introduction where AI can be used in the healthcare. And so then you have to measure. Now, what is AI metrology? It's a science of measurements. And as you can see that there are several aspects of this thing. It's just not one thing, but it's several things. Like you have standards, performance of the systems, trustworthiness, adaptability. The system has to explain. Interpretability means that the system produces something and you have to interpret on what it means. Reproducibility, as you all know, utility, uncertainty quantification, will come to that, traceability and composability, because we're talking about all systems put together. Can it take about 10-15 minutes more to?
Yes, please.
Okay. So it's my particular division called Software and Systems Division. There are people at other places also do, but these are some of the activities that we do. We do performance evaluation, we support standards development, we quantify uncertainty, we detect Trojans, help in detecting Trojans. Then we look at large language models and we identify metrics for evaluating LLMs. So in terms of evaluating performance, we actually build the hardware and software within my own division. So you can see that the kinds of things that we have, NVIDIA systems and other systems, where we almost have about 3.2 terabytes of GPU. There's a GPU and there's a CPU, about 3.2 terabytes of GPU memory, which is spread across 22 nodes. And the reason here that we have developed, but the whole thing costs about $2.5 million here. So if someone is interested in their organization to develop the appropriate hardware, let us know. We can probably give some advice on that thing, because we have experience in setting this thing up. Okay. Now, the advantage of doing this thing is these AI models run locally. What I mean by do not phone home is, now one of the problems with the large language models is, a lot of times in hospitals, they don't want their patient data, they don't want their expertise to go out. So how do they deal with it? They deal with it by having it locally and not going outside into outside world and do Gemini.ai or something like that, or LLM, MedLlama, and those kinds of things. Instead of that, they can have it in-house if you have this kind of hardware. Now, in terms of the standards development, again, this is very briefly, I'll go through this thing. We are actually developing a standards representation, a language based on something called category theory. And what we believe, again, in the future, you've seen all these AI neural networks and things like that. To represent the fundamental knowledge, you need to have something like category theory, which can represent a whole host of things. Like, for example, when you're talking about knowledge representation, some of you might have heard of XML and those kinds of things. This could be used for certain things like syntactic interoperability. But if you want to do anything, like if you want to exchange semantics, if you want to do anything with that, then you need to have logic and so on. And this category theory can actually represent this whole lot of stuff. In addition, especially when you're talking about medical devices and so on, it can also represent the mechanical behavior of these systems. So we are the world leading experts in applied category theory. And in the future, this will be I'm talking about the present, but also in the future, this will play a major role in AI. Okay, so using these things, we developed a natural language understanding system, which will kind of represent standards formally. Why is this useful? Because there are a lot of standards in the healthcare world, One of the standards is this HL7, for those of you who know HL7 fire standard. So what our system does is it takes take the clinical document architecture, and it produces what is known as this knowledge graph based on the categorical theory. And then you can query that so that you can do knowledge retrieval, you can do error detection, you can do dependency management. Because what happens in the standards is a lot of times the one particular term is pointing to another term, which is pointing back to this old term and all those things. So we can actually detect all of them automatically. So and again, we think, because we are developing it, this is fundamental in standards, not only for AI in healthcare, but also across the standards world. Okay, so this can be used to identify errors, knowledge retrieval, dependency management. Okay. Now, quantifying uncertainty. This is, again, very important in the medical field as such. Like what happens right now is that you take, this is for digital pathology, for example, you do a lot of this imaging and you train your AI system based on the based on millions of this data coming in. But then what happens is that there's something called the out of distribution inputs. That inputs you are actually not been trained before, but they are somewhere. Okay, and things which are very close to what you have seen, the system will kind of is okay, it accurately predicts. But things which are a little bit out of this distribution, the system has a problem, and you have to quantify uncertainty associated with it. So what you do is that, as in here, the way that we look at it is that if any of this new thing that image that you show, if it looks like if it's out of that distribution, then we send it to the pathologist here in its digital thing. If it is within our framework, we don't need the pathologist. We are with a very high accuracy. We know that it's a low uncertainty, so we can go directly to the oncologist. Otherwise, we need to get the help of a pathologist so it can be more reliable. So this is what we do. And I don't want to go into details because this is some implementation on how actually we can make this happen, because we probe into these neural networks and we have an idea about what are the things which are within the trained model and what is not aligned with the trained model, which could be unreliable. And this uncertainty quantification is very important. Again, we are working on this detecting Trojans, where, as I said, this adversarial AI attacks insert. So people can insert Trojans. They can insert this in 3 places. One place is the input. They can change the input, manipulate the input. The second one is they can manipulate this learned model. And the third one is that they can manipulate the output, like as you have seen in that thing. So we have worked with ARPA-H to develop the metrics, and we have developed a leaderboard. And again, if anyone's interested, we can go into details later on. This is my talk here is only giving an overview of what's happening in the thing. Then the large language models are ones that we have heard about now, like ChatGPT and so on and so forth. So what we have is that we have what is known as developed something called an AI observatory, where actually we take all this, like in this case, the publications. Actually, this was initially developed, the CDCS was initially developed when COVID came into picture. So there were thousands of millions of documents being generated. So we kind of took all those PDF documents and we put it in this database called CDS, and we could then help the physician or researcher in the search or doing the Google-like search, but in a more intelligent manner based on the knowledge structures that we have developed. So we use the same thing now, extended it so that we have now it goes into this. We can kind of work with several LLMs. So we have an LLM server which has different types of LLMs, and you can actually do the following thing. So you can see that, well, listen, I want to know which is the best LLM for the kinds of things that I'm doing. So you can experiment that and see with various LLMs and see which is the one. But then LLMs tend to do what is known as, they call it hallucination. But someone said that these are not hallucinations, but they're really bullshitting, because hallucination, like someone schizophrenia, for example, they're hallucinating. You think they're hearing all kinds of things and so on and so forth. But whereas that is not what this is. This is more in terms of the system is kind of putting out something which is not right, because the way that it's the way it works. Okay. So we have all these LLMs available in our thing, and we can We can do a lot of things along with that thing. Okay, so we can do that. So then the next thing that we have developed is we written this paper called what are the metrics for evaluating the effectiveness of healthcare conversations powered by generative AI. So I got together with people at several organizations, and we wrote this paper called Foundation Metrics for Evaluating Effectiveness of Healthcare Conversations. This paper was number 6 on the most cited papers in NPJ, Nature's Digital Medicine. And that's pretty neat because that's a pretty high impact journal. And here there are different kinds of metrics when you're trying to evaluate. There are what are known as the intrinsic metrics and the extrinsic metrics. The intrinsic metrics are used quite a lot in natural language processing. We have at NIST we do evaluation of various things like face recognitions, text, and so on and so forth. Those intrinsic metrics are very good, but the extrinsic medicine kind of requires the user's perspective also, in addition to automatically doing it. And so we have identified several kinds of these metrics in terms of for accuracy, for trustworthiness, for empathy, and this performance. So the paper kind of outlines various kind of metrics, and it tells you which are the toxicity, the lack of privacy, lack of empathy, and so on and so forth. So you can see these metrics which we identified. And someone has to kind of go and use this to actually do the evaluations. Okay, and this is the kind of framework for this whole evaluation process, and just skipping through it. So my next set of slides talks about how you can use AI for metrology. And since we do not have time, I'm going to wind up in 5 minutes by giving an example. We actually use right now, that's the talk that I gave before is more about measuring AI. Now, how do you use AI to measure things? So there are a number of examples that we have, but one of the things that I'm going to talk about is this thing called, some people have what is known as an age-related macular degeneration. I mean, there is a dry case and the wet case. So treatment of that, if you look at it next, so about 11 million people in US kind of have this thing. So you have this blood vision. So what you can do is that you can do a stem cell transplant on these people so that they can get a 20/20 vision. Now, why is this problem important? A lot of, like me, for example, as this gene, which is a mutation that I could potentially get this age-related macular degeneration. But I'm not worried because my people have done something interesting, what they do was that they take this to the way that currently it's done is you have this stem cells, pluripotent stem cells, and you grow that in a petri dish over 6 to 9 months, and then only some of the stem cells can be implanted in the eye, and you want to know which are the stem cells which are good, so that you don't want to put all kinds of stem cells in your eye. So for that is what we do. What we have done, we go to the biologists, and then they take this photographs of these cells while they're growing, and then we kind of identify and then we do some processing on that, give it back to them. They identify the features, and our machine learning systems kind of learn which are the things which could be good, which are the things which could be bad, and then this process goes on until we develop, until our system learns how to classify the stem cells which are going to be good. So the confidence in this is increased. And in fact, based on this particular thing, NIH, we worked closely with NIH, FDA approved, and a patient got the first stem cell transplant based on these things for age-related macular degeneration. Okay, so, and this whole technique that we have. So I'm going to kind of skip to the rest of the slides because they're in concrete, all kinds of things. We're building better software. And now I'm going to summarize a little bit in terms of, I talked about metrology for AI and AI for metrology. Standards introduced at the right time will lead to innovation. So then we need to have testing. We need to have benchmarks. We need to have data sets. Where are you going to have benchmarks? Where are you going to have the data sets? And that's where NIST comes into picture. This is for AI for software engineering, a report which I led last year. It's U.S. leadership in software engineering and AI engineering. Again, I participated in the National AI Research and Development Strategic Plan. We have identified 9 particular strategies in there. You can have a look at that thing. Now, if you look at the future's doctor's office, it kind of looks like this. Here is a doctor talking to a patient. And then, right now what happens is most of the time the doctors are typing on the screen such. But what will happen in the future is that you'll have this. This is what this presentation I gave about 1 year ago to a bunch of doctors in Morocco. And I said, well, you have to have a microphone, and this video camera here will kind of detect emotions. We actually do some work on emotion recognition. Like we can look at the person talking and we'll know what kind of emotion that person has. Like, for example, the patient says that he has some disease, but actually he's smiling and telling his stomach is paining. That could not, then you can have to, the doctor immediately detects it. So then I thought, yeah, this is a great idea. But then I visited this hospital called AIG when I went in December, and they showed me something like this, which I'm going to show you next. Now, the conversation is going to happen between a doctor and a patient. Okay. Now, the patient is going to talk in an Indian language called Hindi and also English. So pardon me for those people who do not understand Hindi, but it's a language which it could be English too. Okay. Oh yeah, and the idea is that once they do this thing, this is automatically the notes are generated and ChatGPT checks it and so on. And this is, I thought, was the future about a year ago. But here is what I saw there.
क्या नाम?
राजेश सर।
क्या तकलीफ है राजेश?
सर पेट में बहुत दर्द हो रहा है सर, एंड इधर बहुत क्या पेन आ रहा है सर।
ये कितने दिन से हो रहा है?
सर 2-3 मंथ से हो रहा है सर।
2-3 मंथ?
यस सर।
और जो जलन हो रहा है ज्यादा छाती में?
यस सर, ज्यादा हो रहा है सर।
नाजिया या वॉमिटिंग है?
यस सर।
भूख कैसा अच्छा है?
यस सर।
भूख ठीक है?
यस सर।
और मोशंस का कोई प्रॉब्लम है क्या?
मोशंस नॉर्मल सर।
स्टूल्स नॉर्मल?
यस सर।
और कुछ प्रॉब्लम्स है पास्ट में, कुछ डायबिटीज या बीपी का तो नहीं?
नो।
हाइपरटेंशन?
नो सर।
ये प्रॉब्लम जो है ना, तो कुछ पेरेंट्स को भी है?
So
yes sir, my parents को भी है।
He is speaking in Hindi.
Yes sir. Yes sir.
You can speak in English. You can speak in many of the Indian languages. The conversation between the patient and the doctor.
Your diagnosis looks like peptic ulcer.
Now it's talking in English.
So we'll have to do endoscopy and ultrasound. Before that, I'll start your medications. Pantoprazole 40 mg daily. Once we do endoscopy, we'll give it final.
Now, the guy on the right is the world's leading gastroenterologist. Received Padma Bhushan recently. Not recently, about 10 years ago. But you can see here all that even the conversation was in Hindi. Everything was translated into the patient note here. Okay, history, physical, in the electronic medical record. Okay, and this system is interesting because if the doctor has been talking about the patient's family history and not a family history, but marriages and things like that, it won't record it. It only records the pertinent medical history only. And this history and diagnosis, this note is automatically put in the electronic health record. So, and this is done by using their speech processing system, just hearing the whole thing, and it automatically records, translates it, and puts it in the EMR. Of course, you got to test these things. Okay. So anyway, it's based on the work of several people and NIST, and thanks to all. And I'm going to stop at this stage. I hope that was okay.
A fascinating presentation, Dr. Sriram. It's amazing the kind of work that's already taking place in NIST, and your group is taking the leadership position in AI as well as across the industry segments. Let me come back. I've got a couple of questions. I'm going to come back to the healthcare space. If you look at the health and life sciences, which is about $5 trillion worth of industry GDP, it's almost 20% and approaching. It consists of everything: delivery systems, you've got pharma, you've got insurers, you've got med devices, and on and on. Some are product companies, and bulk of the innovation in the country has happened through devices in the last, say, 50 to 75 years. Now, with infusion of software, how does the CEO, CFO, CIO deal with that in the coming time, especially with the introduction of AI?
Yeah, it's a very good question, because there are, I didn't have time to go into the medical part of it in a little more detail in terms of the domains. If you look at the field if you look at AI applications in medicine, there are three aspects to it. One are the patients, because patients are looking into ChatGPT and things like that, and they're trying to kind of figure out before they even go to the doctor. Many of them put some symptoms and then they have their own things chatting with them. And the second one is the hospitals and the doctors, the physicians. That's one. And the third are the administrators. Okay, so these are used in these three parts. So in terms of the medical field, the hospitals, the physicians, and those people, there are several dimensions there also in there. One is the medical devices. Okay, so the medical devices, especially when you're talking about wearable devices and so on. So these devices are going to be an integral part of it, which is creating our sensors. In fact, I have a whole talk on smart networks, how you have the sensors and how it can be incorporated into your electronic health record and so on and so forth. Okay, so that is happening. So the medical devices now are actually becoming smart devices. They're not just medical, like if you look continuous glucose monitoring and those kinds of things, they're not, of course, continuing glucose monitoring, one of the things it does is it only does interstitial fluids around here. It doesn't do the actual, there is some interesting conversation going on whether that's a good indicator or not, because the blood actually tells you much more detail than your fluid in your muscles or whatever it is, because it may give some other indications. So these are the things need to be taken. The AI system has to take into account as such. So the medical devices have there's a design of the device. AI can be used in the design of the device. AI can be used in the design of the software of the device. And AI can be used, and then you get the device, and the device uses AI to monitor things and so on. So within each device, you can do those things. And then these devices are now integrated into electronic health records. So then you have AI there also in terms of determining whether someone will have sepsis. Of course, there's this famous case with Epic on the sepsis thing, but depending on the test data and so on and so forth, that's where you need neurosymbolic computing there. So that particular AI can also help around there. So there are different aspects of this healthcare that AI can play a role. I just gave you two examples, the medical devices and the EHRs, but there are a whole lot of other things. Did that answer your question?
Yeah. So yes, it does. So it leads me to another question, which is, let's stick for a moment with medical devices, right? There's as you described, how it's embedded and it can be used around it with the use or developing the product. How are NIST standards being accepted by the industry at large? Is there any work done which is specific to standards for, say, device industry?
Okay, so the only thing that we work very closely with FDA and other organizations, but that only at the interoperability of medical device information. That's where we are. We have not done much work in again, we're a small organization, so depending on the scope that we work with, we are now getting to work with ARPA-H and other organizations, so that we'll expand a little bit more. But given the constraints of who we are, right now we are only working with interoperability in medical devices, that's all. We have not done AI in medical devices yet. No. But there's all this trustworthiness and things like that which we need to work on. The answer is no, we have not done much work in that area.
Then let me, and again, what I'm understanding is that NIST is in early stages of getting into the healthcare space and coming out with standards, right? Because there will be different standards, just as it has happened in the manufacturing sector. It's not just one standard; they evolve. So, and you rightly pointed out, the patient comes in, delivery systems come, and then all the support areas, pharma, insurance, and devices, extra, come together for an integrated solution for the patient. So my question pertains to, say, the insurers. How do you think that insurance companies will either be impacted? A lot of this AI solutions with insurance companies are going to be internal relative to their own solutions that are already in place. How do you see some of these companies that are support companies, and particularly for a moment, insurers? How does AI standard from NIST will help them?
Well, yeah, it's a good question because we have not done much work on that. But like, for example, prior authorization, so the AI can play a major role in prior authorization because it can take that things from the electronic records and automatically process it and send it back to you saying that you can give an explanation why it's been denied or not. So those things can be done, but there are no standards for it yet.
Yeah. So
One has to
because
develop
there's so many, yeah, there are so many insurers. So and each insurer is going to do whatever development suits their best interest, and of course with the bottom line in mind, because NIST is basically end of the day about promoting innovation in the United States, right? So is there an opportunity to work across with the insurance industry that pertains to healthcare to help develop standards so that they have uniformity upstream rather than a year, 5 years, 10 years from now when a lot of AI related work has matured and has been embedded and is being used. So how does the industry get engaged with you upstream rather than downstream for development of the standards?
Yeah, so there are, so with working with NIST in terms of scope, we only have certain resources within NIST. So we have to work with, we have to prioritize based on the resources. Like, for example, ARPA-H, when we work with ARPA-H, for example, the Trojan AI, which I showed, it was funded by IARPA. So they gave us the money, additional money, so we could get additional resources and to work on those kinds of things. So it all depends on who's where is the money coming from and those kinds of. We have the tech. What we have is two things: neutrality and technical expertise. So we can provide that. But what it all depends on, we are already committed to so many things. Like, for example, when you go to the doctor and the doctor uses an electronic health record, and that electronic health record has to be certified using certain tests, and all those tests were developed by us. So we spend a lot of effort trying to maintain those things. So even the routine stuff, not even the AI stuff, even the routine stuff, that we spend a lot of effort. So there's, again, it costs a question of resources. We can only do certain things, and depending on that, and we do things which are peripherally AI related things that I talked about. We do a lot of work on Alzheimer's and all kinds of things, but those are some things that we do out of interest. We have some little money in terms of what we know as STRS, and we do with that, but the things have changed over the last 2 years.
So what I'm hearing from you that obviously as a government entity, your resource constrained. So a lot depends upon what the Congress comes up with and
exactly
approved. So my question again is: have you have scanned the healthcare ecosystem, and lack of standards of AI will create risks in one vertical versus the other more than less. Is there any assessment done as to which of these verticals are susceptible to more risk and problems if AI standards are not defined early enough?
I know that's a very important question. The answer is no.
The answer is no.
We have not done anything so far. Again, as I said, that we depend on it depends on the need, on a need basis kind of thing.
Right. Ikram, I don't want to take your time away. If you have any questions that you've been able to put together, please, because I'm sure the audience would like to have their questions asked as well. So please go ahead.
Thanks, Gopal. Ram, it was very insightful and very timely conversation about metrology. And we have been hearing that this is what, when things are flushing out, the pace and things the industry wants, need to have standards in place. So we don't have much time, even though I have so many questions about this topic, which I've received from audience, and some of it's mine, but I will try to see that how many I can cover it, one or two. So one is that you mentioned about AI role in metrology and trustworthiness, and you said that's not much work NIST have done on developing that. So do you know any examples as such in that space which other governments across the world which have developed, or some other industry partners have developed some work, or academia have developed certain framework or standard to look into the bias and fairness of the AI models?
So, there is a lot of work going on in AI. No, I actually correct myself a little bit. NIST is working on the trustworthiness, but not so much in the medical domain. That's what it is. Okay, in the healthcare domain, we need to apply those things, and we have not really applied as a fact. But however, we are working again with organizations right now. In the future, the answer may be different depending on our collaborations with ARPA-H and other organizations which we work closely with. So it may change in terms of applications. But there is one, again, I'll send you a link to a panel that I held at AAAS, American Association of the Advancement of Science, on trust and bias in the healthcare world. Okay, now what is the problem there and who is working on that area? So that might give you some good idea in terms of the trust and bias on trustworthiness, the bias and how the medical field is looking at it. So there are organizations here, a number of one of the organizations that which is looking into some of these things, which they have not really done much in those things, but I think they have an interest. It used to be called Office of the National Coordinator for Healthcare. Now they've changed their name to ASTP or something like that. So
Yes.
they are the organization which could potentially do things, but most of the time they've been spending on interoperability of systems as such. They've not given, they want to hire in, I don't know, health and AI specialist or something like that. I don't know whether they've done it or not. So that's the kind of thing it is, but the universities are doing their work on that, like Carnegie Mellon and MIT and those places. Stanford is a place which is working on some of these trustworthy AIs and how do you measure these LLMs and so on. So this activity is going on outside in terms of measuring things. Because
Thank you.
trustworthy AI is a very important topic, and I think that NSF has also as a research. They have this AI institutes, and one of the AI institutes talks about trustworthiness. Now, trustworthiness is very interesting. It's a philosophy, and we can talk forever on what do you mean by trustworthiness kind of thing. What are the attributes of trustworthiness? And at some point, I kind of wrote a small piece on mapping the Buddhist philosophy into trustworthiness. What are the noble truths of trustworthiness?
Interesting, very interesting. Ikram, I know you have more questions. We have just a couple of minutes left. Maybe we can summarize those questions and forward them to Ram, and maybe we can get some answers for our audience as well. I know you summarized one question at least from them. I think we are approaching only 2 minutes left. Yeah, go ahead. Go ahead, Ikram.
Yeah, so before closing, I like to hear Ram's final thought because this area is developing AI in metrology or metrology in AI. And what's your suggestion and advice to the researcher, those who are looking into, because a lot of people are hearing and going to hear this talk. So what's your advice to that side of the world?
Yeah, so Ikram, is a good question, but it all depends on what kind of research you're working on is a key thing. Okay, depending on, as I said, there's several dimensions to it. If you're looking at the value-based care, it's a different thing rather than if you are working on, let's say, images. Okay, just the images itself. Okay, that's a whole different ballgame completely. Okay, because people kind of have done a lot of work on image recognition and especially breast cancer and those kinds of things they have done. But the important thing there is that from our perspective, if we're talking about images, I talked about this uncertainty quantification in images. That becomes very important. That's one of the areas that I would be working on. The other area which I think is very important, which not many people in AI are working on it really, even in the academic world, is this whole notion of standards. How do you interpret AI standards? Okay, how do you interpret AI documents? So how do you do this automatically rather than people going through it? And that's another fundamental research. It's a very good research area, even for the academicians who want to get into it. In terms of it involves natural language processing, it involves neural-based kind of computing, it involves symbolic computing, it involves standards. So it involves very close collaboration with industry on standards, this particular thing, because industry and standards organization should be interested in that.
So you think the CEOs can play a role in championing development of standards?
Exactly.
Would you say that?
Yeah, I agree with you.
The CEO and the boards of these major companies should be coming forth and saying,
they should be coming,
here's the leadership opportunity to focus on standards upstream rather than downstream.
Yeah, because
Dr. Sriram, we are just running out of time. We're exactly 11:30. We respect your time and we appreciate the time you've spent with us this morning. It's been wonderful discussion, and I'm sure we would like to have you back again. We are preparing for our summit in June. There'll be more on that. We'll be sending out to you and others. To the public at large. And I'm hoping that people will join in for our June 10th and 11th summit and participate and hear you speak again. So thank you
Thank you very
once
much. Thank you
again.
for giving the opportunity, and I enjoyed talking. And as I said, that we had to compress a lot of material. Again, I'll be glad to talk on any of the topics anytime.
Thank you so much.
Thank you so much. And thank you for your service. Appreciate that.
Thank you.
Thank you. Thank you.